Welcome back everyone. I request you to please settle down as we move on to our last session. Thank you. Our last and final session starts with a panel discussion, and to take things further, I would like to request Captain Deepak Singh, COO, the Marine and Offshore Surveys, Aries Group, to kindly take over the dais and tell us more about what the session has in store for us. Captain Deepak Vijay Singh is a Master Mariner by profession with Master Class 1 Unlimited Certificate of Competency. He started his career in 1993 in the Merchant Navy and gained working experience on all classes of bulkers. He has over 22 years of vast experience in the marine and offshore industry and has been associated with some finest and renowned organizations. Mr. Singh also holds a DP Operators Certificate from Nautical Institute UK, and he is an Offshore Vessel Inspection Database OVID Training Course accredited surveyor, holder of International General Certificate in HSE from NEBOSH, and a member of Nautical Institute. Sir, I request you to please take over the dais.
Thank you, Ashish. Good afternoon, ladies and gentlemen. Our panel discussion for this afternoon is safe ocean towing, and it is a very relevant topic for this area in this region. Given the amount of oil and gas activity going on in this region, I don't think there would be a single day when there would not be something being towed out to the oil and gas fields offshore. So for the panel discussion, I would like to invite the following gentlemen to join me on the stage, please. Mr. Gulab Ramchandani from Tasnif, Captain Shivasankar from Gulf Agency Company, Captain Osama Sultan from the Federal Transport Authority, and Captain Mohammad Al-Shaif from Alliance. Thank you, gentlemen. I think Captain Osama may join us in a few minutes. We can go ahead and start the discussion. I think we have a good mix on the panel today from tug and ship operators, agencies, classification society, and also from the regulatory bodies like FTA. So we'll get an overall view of how and why the towing operations need to be looked at closely and what are the safety measures to make sure that things don't go wrong. So the first thing I would like to check is, probably Mr. Ramchandani would be able to answer this better. In most of the regulatory framework in the marine, whether it is MARPOL or SOLAS, everything is statutorily required by the flag states. But when it comes to towing, there are no international accepted benchmarks as such, because they are all guidelines. So why is this anomaly there, sir?
See, these all requirements, when they are developed, it has to be coming in the IMO, then it has to be through the flag states. So they have to ratify those requirements. So MARPOL, SOLAS and all, they are all ratified by the flag state. However, these guidelines are not coming through any of the SOLAS or MARPOL requirements or some statutory adopted by the IMO convention. So these are not coming through the FTA and it cannot be implemented. So, but looking at the safety requirement during towing and all, IMO has developed these guidelines. However, these guidelines are incorporated. Some of these requirements are already incorporated, like in 2016 through MSC 415, like stability requirement for the tugs, escort tugs and all, these requirements already incorporated wide intake stability, and which are going to come in force in 2020. So some of the requirements are there, but these operations are like it is only for the operational purpose. It is so these requirements are specific for operation requirement, hence it is not coming in the statutory requirement. So this is...
Okay, well understood, Captain A, and that's probably the reason why there are different guidelines from different bodies, and there is some difference in all the regions in the world on what is the normal practice based on what guideline is prevalent over there.
Yeah, like passenger vessel and cargo vessel, there are some requirement like emergency towing arrangement should be on board. So these are statutory requirement coming through SOLAS, but those are only related to emergency requirement, not as the towing operation as such. So some of the requirements are already there and some are going to come in 2020 as well.
So you touched upon one topic there saying escort tug notification and it is coming in future in 2020. And I think it would be a good idea to get some information from you on the basic difference between a normal tug and an escort tug, because I believe the escort tug has very specific requirements.
Yeah, see, normal tug, the operation is towing and like pulling and pushing, all these requirement, there are three types of tug operation normally they do, like the push and pull and the direct pulling requirement, and then is the escort towing. So these are the new requirement, means this has come because of the accident of the Exxon oil tanker. So the tanker was heading at the speed of around 7 to 10 knots, and which the normal tug cannot control, because the tug, the propulsion power only gives control until say 5 to 6 knots, and beyond that the tug could not control it. So the new development happened, and because of the hull shape, the hydrodynamics, the lift and the drag force which is being generated through this escort tugs, and there is an indirect towing arrangement, like it has to be, the tug has to be on the aft side and it can pull. So only the propulsion power is sufficient for giving the direction to the tug, but for controlling and controlling the tug to reduce their speed, that hull shape, the hydrodynamic comes into the force. So these escort tugs are basically used when your speed is more than 7 to 10 knots. Otherwise, other conventional tug can also utilize if the speed is less than that.
Well noted, sir. I think the big takeaway here is that, like you said, the hull form is what is more important to get an escort notation, and only at that speed is it really useful to slow down the vessel. And I think that's something which is not easily understood, and a lot of people still in the industry didn't understand the difference. So I thank you for that. And moving on to probably operations, and Captain, what do you think are the main risks associated with ocean towing, and how probably does, as an operator, how do you try and mitigate those risks in your company?
And in my opinion, for the main risks, the first priority is the weather. So we need to choose the suitable weather and receive the suitable weather forecast, and also to identify, in case of ocean towing, need to identify the port of refuge, and also using defective tools. Tools should be inspected regularly, every 6 months, and sometimes, in my experience, I saw some tugs are faking the Polar Pool certificates, so this should be done through approved third party. And incompetent crew should be recruited for this operation, and following the safe working practice and proper procedures.
I think you're bang on when you said that in this region sometimes you find fake towing certificates, and it has been my experience that yes, there are, I wouldn't go to the extent of calling them fake, but at least questionable certificates do in the market. So you're very right, yeah, that is something which does get overlooked in all the operational planning, so it's very important to plan it well as well, yeah. And moving on, any incidents, lessons learned in any of your fleet captains, whether you have any any incident happened and then you change some of your procedures or policies?
Sure, thanks for this, Deepak, appreciate it. Good afternoon, everyone. Okay, towing, we learn everything, on marine life. I think we have to learn every day almost. some of the things are taken for granted. Few things that we picked up operationally was, we do inspection of loose towing gears every 6 months, which is a requirement. But people tend to forget, when you're towing a vessel, it's your day-to-day operations. So you need to check your towing gear prior to every operations. It's not every 6 months. There can be damages. You could have done an examination today, but tomorrow there could be an accident or damage to your towing gear. So it has to be inspected. And number two is, in the towing winch, there are some latches installed as well because the brakes are not holding well. So some resort to mechanical stopping device, such as latches.
Yeah, Paul.
That's in fact is dangerous because we have brakes for a reason. Brake is supposed to pay off when there's excessive load on your tow wire. So if it doesn't pay off, you can imagine, either the wires will part and it can result in serious injury.
Yeah, in fact, very well noted, Captain. You're bang on there as well. I think a few years back there was an incident where a vessel towing on stopper, dog, what they call in this region. I think in the Far East they call it dog, over here it's pawl and ratchet or stopper. But the tug lost power and the weather was bad. So they couldn't release the tow line and the barge drifted to the shore and with it the tug also went aground. The both of them just drifted short. So you're very right, it should not be used.
Yeah. The other common thing we see in this region is like you have 12,000 deadweight rock barges.
Yes.
And I'm in marketing, so you get, they want, obviously the charterer wants the cheapest tug. So if you go for a bigger tug, you need to pay more. So 2,000 BHP is good enough to tow 12,000. It's impossible to do that.
Yeah, I think we know what you mean.
This is now where the approved. Good afternoon, gentlemen. This is where the approved towing companies' expertise and they exercise their expertise on towing approval certificate. So they cannot issue a towing certificate unless they are making sure the proper and adequate equipments are provided.
That's excellent.
And sufficient tug power for this type of tow and tow line and all the procedure as per IMO resolution are in place. Actually, we, as the Federal Transport Authority, we circulate a memo for all UAE boards stating that there is no any towing operation if there is no towing certificate issued from approved company by Federal Transport Authority. We have a criteria to approve the towing company. At the present, maybe there is six companies are approved only, and there is a few already. They have submit their profiles, company profiles to get approval. As you said, Captain, it's a very critical and very sensitive operation and very dangerous operation if it's not prepared well from owner side and from shipmaster and from towing approval companies to make sure all the procedure are in place. This is what's Federal Transport Authority now. We know this is very as previous year there is a lot of accidents, and the accidents actually it's a major. When the barge or tugs hit one platforms, or there is one boat in not in the Abu Dhabi port in Mina Zayed. It's been sunk inside the port, and there is a few people also being lost their life because of they cannot release the what you call the towing line, because there is no quick release. So there is a lesson learned. So for those reasons, we are having a very now not strong, we can say. There is a procedure to approve certain towing company, and with Tasnif as well. They are our technical support experience. They putting some requirements for this type of activity.
That's excellent, Captain. Good to hear that.
I think I can confidently say that over the past at least 3 or 4 years, there wouldn't be a single winter without at least one incident of a barge going aground. And typically the barges that Captain Shiva mentioned, towing aggregate or rock from Ras Al Khaimah to Bahrain or something, they typically get loaded to the max. The tug is underpowered because they want to save on fuel, and they used to go aground. But I think with this new initiative from FTA and Tasnif, I think the industry will be thankful to them for going ahead and making these operations much safer, and probably in the future we will not see any more salvage operations of those kind. With that, I would like to thank all the gentlemen for the panel discussion, and we are open to any questions from the floor, please. Anybody wanting to know anything specific about towing? I think from all the angles, we have representation from all sides here.
It's not a question. I just like to add a point. Thanks very much. Everybody just put things in the best shape. And during the past few years, towing any object nowadays go through a certification procedure, which applies by the class and the insurance company of both the tug and the towed object. And that necessitates a lengthy procedure, including calculation of the power requirements for the towed object, the towing gear certifications. So there is, the lesson is learned around the region anyway. It's no more just get the cheapest tug to tow the heaviest barge. No more now. Have to calculate the power requirements, bearing in mind the weather, the area, the region, and the unexpected issue. Thanks very much for your information.
Thanks for that, Mr. Goma. It was really informative, and you are very right that the control is coming in from different phases, also from the insurance side. They are looking at how the warranty certificate is issued for towages. What I would like to add there is probably about a year or year and a half back, there was this trend. I don't know how familiar others are with it, but a lot of the people who are involved in the offshore construction or the dredging market, they have towages on a daily basis. So they had arranged with insurers to start getting approvals remotely without the surveyor visiting the site. Partly the reason was because the market was down and rates were down, everybody wanted to cut costs. But I personally I saw the trend start, but then I think now it is pretty down. I don't see much, but I would invite your opinions on what do you think do you think people, if they are doing it on a daily basis, do you think remote certification is the way forward, or is it absolute no? Because we have the regulatory bodies here, we have class, they would have some opinion on this.
No, as far as as far as Tasnif is concerned, we don't do this kind of thing. Every tow, every time it has to be surveyed before, and it is given on the voyage basis, not on the
combination
1 month or like that. No. So it is only for particular voyage it is given, because the requirement of weather condition and all are different. Every day it is different. So it is basically for per voyage only.
Yes, I personally, as a master and having sailed offshore, I couldn't agree with that more. Each operation is a single operation, but I raised the topic because there have been instances where underwriters, for whatever reasons, have agreed to different kind of arrangements, and it's just a question of unification of everybody's ideas, and it's good that Tasnif and FTA, I think Captain Osama would probably agree with the same on requirements. Single voyage, yes. Okay. Right. And any other questions, gentlemen?
Captain, I wanted to give you a life experience on a tow break. You know, in 2008, we have moved a tug and barge, brand new from Nanjing, China to Abu Dhabi. The condition of weather forecast was very good. Tower was connected, brand new tug and barge. The tower was connected, it is certified by the warranty surveyor, it was counter-certified by the Chinese Classification Society, the tug and barge were certified by ABS class, and I waved hands to the master, very good, sail. It sailed out from Nanjing, it crossed Shanghai, it came to the Taiwanese Strait. The weather became very bad and the tow wire broke. The water was flashing on top of the bridge. Emergency rescue team from Hong Kong was flown by air, the crew was evacuated. I flown from Abu Dhabi and I went to Taipei where they were rescued. The tug reached after a week to China and the barge reached to Vietnam. It is not that we are not looking into the thing. In spite of you having all the precautions, all the safety norms being protected, the acts of God is very great. It's much above than what you can do. That particular time of the year, about 12 bulk carriers sank in the South China Sea. And my tow wire was also broken at that time. But we rescued. Thanks.
Thank you, Mr. Varghese, for that interesting episode. And you are very right in the fact that act of God is, and that is why the term is there, act of God. And you cannot really plan or make a guarantee against something like that. Then that's another way to look at it, because you got the insurance money because you followed all the best practices. And that is what the regulatory authorities and insurance drives you to go follow the best practice and unify the best practice. And as long as you do that, then, like you said, maybe an act of God, but then you're covered with insurance. So I suppose we've come back to the same thing, that the best we can do is follow the good practice. And all the gentlemen here agree that the new initiative by FTA is going to increase the safety around this region. Any other questions, gentlemen?
I have one question. My name is Uni from ABS, and we are typically classing the vessels, but with the current market conditions, we are seeing a lot of ships, especially barges and the smaller vessels, are getting laid up. And we get a lot of requests to tow these vessels from one place to the other, to either the shipyard, or because the owner doesn't want to put the vessel up there. Because I don't see it from the other side, from the insurance company side or from the towing master side, what are the minimum documents that you look for from that particular vessel? Sometimes we issue a certificate of fitness to proceed under tow, a short-term load line certificate, and we often get asked this question, what surveys you need to do. So we go back and say, what certificates is the port requesting? So this has always been a gray area, at least in my mind. So,
anyone would like to answer that? I don't mind answering that, because I think I've been in charge of a fair number of projects where we took the complete work scope for the towing. So I've seen it from both sides. I've been an owner or operator before, and now I've been working as a surveyor in this market for 10 years. The port generally requires you to have a certificate of approval for towage, or which is also called a certificate of towage. Now the FTA has initiated a new initiative where only authorized bodies can issue this certificate of approval. Am I right, Captain Osman?
Yes, you are right, Captain. But what he need for his questions answer, actually we take case by case. They need no objections from FTA to allow the marine units, you can say, to shift from A to B, like whether to going to dry dock or to go to nearest other place for ship maintenance. Sometimes we request underwater survey from the approved company and through the class, And we need, sometimes we request like a statement from the class that's for single voyage. The ship is fit for, to be shift from A to B. Actually, we study the case by case. It depends on the age of the ship, type of the ship, the area of, where she's going to, from which place to another. So usually it's the maximum is what we request underwater survey, and they make sure there is no any the hull integrity, and she's going anyway for the maintenance and for the dry docking, or so just to make sure she's not going to go under the water after a few miles.
Yeah, that's primarily our concern too. But what we typically, and this comes more when a ship is coming into the UAE, let's say from Oman or somewhere. So we keep getting asked this question: what is the minimum paperwork? So we always direct them to the agent or to contact the local flag state to find out what is the minimum requirements. So I get your answer. That's right. So you look at it on a case-by-case basis. That's correct.
Yeah, I think that's very relevant also, because some ports also have some certain regulations over and above, which may not be primarily only to towing. But then if you give them a package, you need to make sure that the agent, so you're very right in directing to the agents, because even different countries in this region have different requirements and different approved bodies. Any other questions, gentlemen? All right. Thank you for your audience, and thank you, gentlemen, for your time and your participation in the discussion. Thank you. I'll hand over the dais back to Ashish now. Our next presentation for the day is by Mr. Satya Medapur Reddy. Mr. Satya, having 23 plus years of professional experience as a department manager, lead structural, senior engineer, job officer, and offshore and onshore structural works for various projects with esteemed organizations of Tebodin Middle East, ADMA OPCO, Worley Parsons, Mott MacDonald, Engineers India Limited. Presently working as department manager in the offshore structures with Tebodin Middle East, he did his post-graduation in civil engineering from IIT Madras and graduation from Andhra University, India. He received various recognition awards from ADMA OPCO for developing qualitative risk ranking of all existing structures in ADMA fields. Innovation Award for developing regional acceptance criteria for Gulf of Arabia in association with API committee members in 2010. Assessment of Zakhum WI pipeline replacement critical lines in 2010. I call upon the stage Mr. Satya Medapur Reddy, please.
Thank you for your nice introduction.
Check. Maintaining
structural integrity of offshore structures is a very challenging job for offshore structural engineers, asset managers, and integrity engineers. Part of these structures underwater, which are not accessible for visual inspection, is very difficult task to maintain. Apart from that, life extension of offshore structures which have passed the design life is another challenging job for the offshore structures. Respected Chairman, event managers, ladies and gentlemen, good afternoon. I thank the organizers giving this opportunity to present my topic on structural integrity management of offshore structures. I will briefly talk about Tebodin profile, what Tebodin is going to do, are doing, structural assessment process, what is all the process about the structural assessment. One case study, we have done so many projects, but I will present one case study, what type of analysis we have done to qualify the structures, to extend the design life of the structures, and how we calculated the risk-based inspection, RBI, and risk ranking, and how we have defined the inspection plans for the particular client. This Tebodin profile, Tebodin commits for safety, quality, and compliance. Tebodin founded in 1945, The Hague, Netherlands is our head office. Presence in Middle East since 1974. Now we are part of Bilfinger Industrial Technologies. We have ample resources, 4,900 engineers worldwide, 2,000 engineers staff in Middle East, 630 engineer staff in Abu Dhabi itself, and out of that, 335 engineer staff in Abu Dhabi oil and gas. We have worldwide offices, 50 offices in 25 countries, and we have long-term relations with clients and having a 75% turnover. So our Middle East organization is like this. We have the managing director, and under him there are country directors, different countries for Bahrain, Oman, Qatar, Saudi, and United Arab Emirates. This is the Middle East oil and gas strength. We have total strength of around 1,500, Qatar 55, Oman and UAE 1,417, and Bahrain 35. This is the Middle East oil and gas organization. We have two directors, country directors. Under them there are managers and directors, and there are here different discipline managers for the process, electrical, instrumentation, civil, offshore structural, and offshore and onshore pipelines and piping specialists. We have capabilities in oil and gas, different studies including feasibility studies, high-end studies, availability modeling, offshore structural design, conceptual design, feed engineering, detail engineering, CapEx, OpEx estimates, value engineering analysis, HSE risk analysis, and procurement assistance, construction management, and supervision, and project management and control. And we are doing in EPC also, up to small jobs, $20 million. This is our area of capability. We have a capabilities in wellhead and flow lines, manifolds and separators, pipeline with pigging facilities, process plants, utilities and offsites, tank farm and jetty, gas distribution networks. I will skip this display capabilities. We have different displays. There is capabilities. And we have the consultancy, project management consultancy services. And under this consultancy, we do process safety, loss prevention and fire safety, occupational safety, asset management, environmental impact assessments and management, specific environmental studies, sustainability related studies. So today I will present only the offshore structural integrity management. As our friend said in morning session, if we can see, we can manage better. But now I am going to give a presentation which we are not able to see. This is underwater. As we all aware, the platforms have jacket and top sides. Top sides, okay, we can see visual inspection. But the part of the structure underwater, which is jacket, so it is very difficult to maintain. For structural assessment, I will show one flow chart. Why you have to do the structural assessment? See, this is, I am talking about only the existing structures, not for the new structures. Why you have to do the structural assessment? When the already structures are standing for so many years. The reasons could be brownfield modifications because of the cost cuttings and all. We are doing the modifications on the existing platforms. The building of the new platforms is costly. Management of change. Sometimes damage occurs due to the impact of boat, ships, and life extension, where the life already, design life already passed, we have to extend the life of those structures. Once this structural life, any of this activity or combination of the activities can trigger the structural assessment. Once the structural assessment is triggered, we have to collect the first data collection. What data is required? We have to collect as-built drawings. There are software files called SACS files, analysis reports, weight control reports, all existing environmental data and geotechnical data for the pile designs. Apart from that, we need the inspection reports, underwater inspection reports, integrity reports, and site visit reports and observations. Once we have this data, we have to check whether this data is sufficient for the analysis. If it is yes, okay, we can go ahead with the analysis. If it's no, what data is required? So then we have to ask for the inspections. Client, please do this inspection. We need this data for the particular assessment. If it is yes, we come to the various analysis we have to perform to make that structure fit for service. The first and primary analysis is in-place analysis. As is condition, what are the loads are affecting on the structure apart from dead loads, equipment loads, and wind, wave, and current. All these loads acts on the structure. So we have to do the first and primary analysis, which is called in-place analysis, to check these members and joints whether these stresses are within the limits or not. Apart from that, we have to do other analysis also, but this is the primary analysis we have to do. This analysis mainly checks the pile factor of safeties, whether pile is required factor of safety or not, and the unity checks of the joints and members, and whether it is compliance with the API RP2A requirements, this codal requirement. If yes, structure is fit for purpose, and go for the update risk ranking. Every structure, the companies will maintain the risk ranking. What is the risk of that particular structure? Depends on the various parameters I will come back to. So based on that, we have to update the risk ranking and pass the structure. If it's no, then only problem actually. So whether they have any mitigation measures, how we can mitigate? Pile is failing, how we can mitigate it? The jacket members are failing, how we can mitigate? Top side members are failing. So you have to see, I will come back to some mitigation measures which we have done for the particular project. We have to check mitigation is possible or feasible. Yes, if the mitigation is feasible, go for the mitigation measures. Before going for the strengthening, we have to mitigate it. And once that mitigation is possible, we have to follow the entire sequence. If it's no, we have to perform the ultimate strength analysis, which is called the pushover analysis, collapse analysis, which will go for the elastics to plastic. This is the plastic analysis, which we take up to the ultimate strength of the structural steel. As per this pushover analysis, we get the reserve strength ratio, RSR, and pile factor of safeties. If there is a codal provision is there, this RSR should meet particular value. If it is yes, structure is fit for service, and we can go for this process. If it's no, structure is not satisfactory, we have to go for the strengthenings. What type of strengthenings? We can do it. What is the cost of the strengthening? We have to analyze all these things. If it is strengthening, yes, then we have to go for the entire sequence. If strengthening is no, then we say this structure is not fit for service. We have to terminate and go for the new structure modifications. So this is the entire structural process, what we do to make that structure fit for service or not fit for the service. This is case study which we have done in the similar fashion for the one of the clients. His client is a oil company based in UAE. So I cannot reveal the company name. This project is 6 months duration, having 7 complex platforms and 15 wellhead towers. This study was certified by the third party also. We have engaged the third party to review our work and certify. So this is about the fitness for service and life action study, including structural integrity assessments and the risk-based inspections to extend the life of the 20 years. So different analysis we have to do. As I said, this in-place analysis, dynamic analysis. The structures will continuously experience the cyclic loading due to the wave and current. So we have to analyze this dynamics also, how much dynamic load is adding this structure. And there is a ultimate strength analysis, pushover analysis, we have to do it to qualify this one. Apart from that, we have to do the fatigue analysis to see the damage of the joints. This will determine the damage of the joints and thereby the life of the joints. Apart from that, we have to do the boat impact analysis also. When the ships comes or boats goes and there is the impact will be there on the structure. So how much impact, whether the structure can sustain that impact or not. And there are some remedial measures which we have done, as I said in my previous slide. Corrosion elements, actual corrosion we have to consider, and redundant equipment load reduction. If the equipment is not operational, remove that equipment, update the soil data and pile capacities, update the environmental data, latest environmental data, because these structures might have designed 30 years and 35 years old. So now the environmental data and the soil data might change. And the deck strengthening and jacket strengthening we have to carry out. So I will show some video how the structure behaves under these loads. I think that link is not working. So this is the in-place condition, how the structure is going to deflect. We design for 1 year and 100 year extreme wave, current and wind conditions. And this is the in-place conditions, and we do the dynamics. So dynamics analysis also under 6 modes, how the structure is behaving under different modes. All together, at different modes. And this is the push-over analysis. 100 load will be applied in incremental until the structure collapse. So each joint will go into the plastic, and that load is transferred into the adjacent joint until this structure collapse or pushed over to large deflections. So this is the ultimate strength analysis. If the structure is not qualifying even with this analysis, then we say we need the strengthening, or if the strengthening is not feasible, the structure is not fit for service. Where are the files? Huh? This one? Okay. So as per API 2 SIMS, same process it says, you have to get the data, collect the data, evaluate, strategy and program. You have to make the inspection programs. Once you do all the analysis, how to make the risk ranking and inspection programs. So these are generally the risk ranking. This will be applicable to all the structures. The risk ranking depends on the probability of failure and the consequence of failure. What is the probability? Whether 100%, 50%, and what is the consequence of the failures? How much cost it will be? And there is a system factor, which is redundancy factor, depends on the importance of individual component. This is based on the ultimate strength analysis. And these probability factors, like I said, there are different analysis: fatigue analysis, accidental damages, anomalies, likelihood of corrosion, confidence in the assessment, utilization factors, and the consequent factors: consequence damage, risk to life, risk to environment, risk to production, and cost of repair. So different factors, we have given the factors. So suppose this RSR, this reserve strength ratio is less than 0.8, we give 1. If it is greater than 1.6, this 0.2. So in between, these are depends on the client to client. We have to agree with these factors with the client. And some examples of the probability factors, like fatigue. If the design life is, say, suppose for the particular field, 111 years, then the category will define as a high. And if it is in between 111 and 150 is medium, then if it is greater than 150 is low. Like this, there are likelihood of corrosion. If this splash zone, high, and if it is above and below splash zone, it's medium. Like the anomalies, based on the inspection reports, if the cracks are there, it's a high category. If there is a pitting, corrosion, medium, and coating, low. And these are depends on the in-place analysis. If the utilization ratios are greater than 0.9, high, and in between 0.9 to 0.85 medium, and less than 0.85 is low. So once we fix these parameters, and there is a consequence factors also like this. If the production is greater than 2000 barrels per day, it is a high risk category of the platform. And also these values will change from client to client. It has to be agreed with the client. In between 500 to 2000 barrels, medium, and less than 500 barrels per day is low. And cost of repairs, again, if it is in the splash zone, and this is extensive damage, then it is very high, and if it is slight, then it is a medium. Like above splash zone and below splash zone also, we categorize these risks. Once we categorize and we define these risks, we have to give the weight factors depending on that particular activity, which is more critical or less critical. Like the fatigue damage to the joints are high. If it is high, the score is 100, and the accidental damage, if there is a happened, that is a high criticality factor, we have to give 100. So like this, high, medium, low, we have to give these factors we have to determine based on the previous experience and the analysis. Once we arrive these weight factors, we have to calculate the risk of each element of the structure. So for the particular field, in this field, what we have done, it is very high critical if it is the total score of this, all the factors is more than 7,500. So high, if it is in between 5,000 to 7,499, and medium 2,000 to 4,999, it's like this. And the inspection category also, we put it actually, the inspection category is 1, 2, 3 or 4. Inspection category 1 means very, very high actually. If the inspection category is priority is high, so these inspection intervals will reduce. We have to inspect regularly. So this is 2 years, every 2 years we have to inspect if it is very high, and 4 years if it is high, and every 5 years if it is medium, and if it is low, 7 to 2 months, and it's very low, it's not required. So based on this risk ranking and the total score, we tell the clients, okay, you have to do the inspections in these intervals. So based on this, once we arrive these intervals, we give the plan, inspection plan. So you do this inspection plan for the next 20 years. The way we go for the checkup for the doctor, as we are old, we have to visit the doctor frequently. The similar way, if it is more critical, they have to inspect more regularly. So these are critical joints which are failed in the fatigue. So that UT weld scans for the fatigue critical joints has to be done, and the level 4 survey as per the APRP 2SIM. And for the routine inspections, depends on the risk, either 2 years, 4 years or 5 years. So we defined for the next 20 years. So what type of routine underwater inspection, level 2, level 3, level 4, it was defined in this code. You have to carry it out. And topside inspection has to be carried out every year as per this portal requirements. So this is the case study which we have done. So thank you very much. Do you have any questions?
And there is some international standards for this offshore units, which is fixed one. And as you explained, thank you very much for your presentation, useful presentation. Based on what this factor and this criteria, and there is also a certificate, international standard, or as your company follow, or this is just as your expertise, your company expertise on this side, you put your standard and your criteria. Can you explain, please, and clarify for?
Yeah, these criteria, how much energy is required, what size of?
Just before we carry on it's in the same manner. You mentioned in your presentation limits, maximum limits, minimum limits. The question actually we've been discussing about, in what basis you have set those limits and the ages, the number of barrel per day and so on. If that's an international standard or guidelines from a classification societies, or it's an own expertise and your own guidelines. Thank you.
No, these are based on the international codes, international codes, and there are regulations, and also this is, this depends on the country to country. Okay, so what is the criticality?
When you come to say country to country, you
Yes.
are defeating the whole object. But when we say codes, guidelines, or standard, this is that doesn't.
Yes. See,
Country-
APRP2A,
Yeah.
APRP2A is the American Petroleum Institute code. Okay? So there are requirements for the US waters, there's a certain requirements is given. Other than US waters, there are certain requirements are given. So this is the international code. Yes, it is there. So, yes, API, American Petroleum Institute, that is the standard code what we use for the design of the structures. APRP2A, APIRP2A. American is, yeah, RP2A. Yeah, so there are different regions.
So you mean America or
Yeah,
So
API.
you are following the same requirement and criteria in other stuff. More or less, and there is North Europe.
See,
I am not specialist on this.
See, what operators here, the operation companies like Yadma, Yadco, Total, based on the API guidelines, they have prepared their own guidelines, okay, which suits their requirements. And for a particular boat impact analysis, what we have a question, so they have to decide, the client tells actually what type of vessel will go, how big vessel will go to that particular structure. So, for the process platforms, we design up to the 200 ton meter displacement.
Certificate, like issued from your side as recognized from them for this individual structure or what?
There is a certificate like for individual units. Like for the ship, there is like class certificate issued from EBS or RINA or international associations for classification society. For this marine offshore units, there is a certain certificates required issued from certain competent authority or competence approved company.
Yeah, these certificates are required at the time of installation for the insurance purpose. These certificates are required from the international standards.
Who's issuing this certificate? This is for my information.
Yeah, there is a certification agencies are there.
Issued from which, from a company as your company, or issued from some like class, classification society, EBS, RINA, or whatever? Or you have no questions, you have no answer?
I don't know which, actually which companies.
Thank you.
But like this, the structural assessment we have done,
This is
the
assessment.
certification issued by the DNV GL.
Okay, this is like.
Okay. So, but for the
So you mean like you are approved from DNV GL
yeah,
for,
they have,
for assessment?
They are the certified company.
They are certified
So
company
they can
or
certify,
assessment? Okay.
like BB, so they have the certification agency.
And
they can
you
certify.
you do the assessment and
We do the assessment and they have to give the certification to qualify the structure.
Okay, thank you.
Okay, there are no more questions. We're coming into the last section. Okay, because we've got 3 more presentations.
Quick one. Hi, I'm Mr. Satya. Sorry, Dev here from ABS. Just a quick one. Actually, you said you have shown some case study for a fixed unit, and also I believe you do similar kind of life extension for jackups as well. I mean, like a drilling unit or something. So my question here is, at which stage the class is being involved when you are doing all this risk assessment and shown the workflow chart? So at what stage class is coming into picture?
So that's what I said. No, there are many factors. One is we have designed, generally we design the 30 years. 30 years for the offshore structure. So 30 years elapsed. So they have to get the insurance. Okay, at the life actions, they need further, 20 years they want to operate because the oil is there. So for that one, we have to do all the analysis and get the certificate, then only the operating company is allowed to operate that particular platform.
Okay, no, I mean after doing each analysis, you are approaching to the class to get it reviewed by them, or you are just
reviewed by them
it is
and
being
certified
reviewed by them. Okay.
Yes.
And one more thing, you also mentioned that you also decide some time frame for the inspection. So is it also aligned with the class inspection?
These are in line with the API, again, API 2SIM, to Structural Integrity Management. So API, they have published the code.
Okay.
So there they have given the guidelines actually.
Okay.
So in general, the 4 years to 6 years are, as the new platforms, the interval is more actually.
Yeah. Okay.
As the platforms are getting old, we have to inspect frequently. So those guidelines as given by the codes only. Within the guidelines, we fix the parameters and calculate this, how much the interval they have to go for the inspections.
Yeah. Thank you.
Thank you very much. Now we are in the last hour of today's presentations. There will be 3 more presentations in this last hour. Let me introduce Mr. Threje can I invite him to the stage, please? He has been with Light Structure AS since May 2013. He has previously held several managing director and sales managers positions in various industries, ranging from information technology to construction industry and management consulting. Prior to joining Light Structures, he was sales and marketing manager Norway of Doku Group. His work for Doku Group included product organization and business development. He holds a Bachelor of Science in Electronics Engineering at NKI in Oslo and a business candidate of Business and Administration degree in Economics at the Norwegian Business School in Oslo. Please welcome Threje. Am I right in that pronunciation?
Yes, quite good.
Thank you.
In my native language, I would say Terje. But in my native language, I would say Terje. Or in English, Terje.
Okay.
It's the same. Thank you for the introduction. And thank you to Mr. Satya. He was here before me. What I'm going to talk about now is kind of monitoring technology that will make some of the engineering job maybe not so necessary anymore. But we need them. We still need them. Excuse me, do you have a pointer here also? Is that this one? Okay, thank you. I would like to, first of all, to introduce Light Structures to the offshore industry in the Middle East. We have been working here for some years with the ship owners and shipyards, and this is the first official introduction to the offshore industry in Middle East. I will tell you a little bit about the technology, how it works, and a lot of what do we mean about monitoring. And I will also like to show some reference projects which we have done in Europe mostly, and also Asia. And a little summary at the end. First of all, Light Structure is a Norwegian technology company, and we are the world leading supplier of autonomous fiber optic structural or hull monitoring solutions. And why do I emphasize on autonomous? It's like Dr. Guma said previously, to reduce human error. We are located in Oslo. We are a spin-off from Norwegian Defense, where the technology was developed more than 20 years ago. We have been an independent and commercial company since 2001. And instead of having a global organization, we have a lot of agents, servers, and sales agents around the world. And here in Middle East, we have a company called Tritech Power and Automation, who also are service engineers supporting our clients, and also sales agents for us. We have sold more than 200 systems to commercial ships in commercial shipping, Navy, and on offshore units, and I would assume that approximately 20% of all the installation we have done is on offshore assets. So this is a well-proven technology. And then the question is, why do we want to monitor? We have good engineering companies, we have good theoretical models. Why do we need to monitor? And our angle on this is to improve safety by quantification of uncertainties. And what do I mean by that? Typical contributors to uncertainties which you are not able to predict or foresee are weather conditions like wind, wave, and current. We can, with our technology, we can monitor the impact and the response of the structures due to this impact or contributions. Our goal is also to reduce the operational cost, the OPEX, and due to having full control of the structural condition of your assets. Reduce frequency of visual inspections or RBIs, risk-based inspections, and by utilizing the technology and that everything that lays in the technology to prolong structural life. And then it's important to utilize all sides of the technology. I will come back to that later. Like this. Very short brief about the technology itself. It's called scientifically fiber Bragg grating. It's about light and light reflections. And we have a sensor here. It's approximately 1 centimeter in size. And it's, to use a layman's word, we use lasers to imprint a certain pattern in a regular optic fiber that will give this fiber some kind of abilities to reflect light. It's called a dielectric mirror, nothing to do with electricity. Another word is Bragg mirror. And what is happening is, if you, for instance, use this FBG1 and call it sensor number 1, if you send light to this, and you know that if it's at rest, it will respond by reflecting light at a certain wavelength. And if these suffer from any kind of stress, that means compression or stretch, you will have a deviation in the reflected light. And that deviation is caught up in the interrogator, and the result is being sent down to some algorithms in a computer, and then you can actually calculate what kind of force that's inflicting on the asset. I'll jump over the scientific explanation of this technology, just to keep it a little bit quick here now. Typical infrastructure is that you have a number of sensors and accelerometers based on fiber optic technology connected to a rack, which is either located in wheelhouse or electrical technical room. And then you can distribute data from that system in two ways. You can either have the real-time data on the vessel itself, showing all the stress levels. You can send the data, or you can connect to the system from onshore and look at it. And we also had discussions about cybersecurity earlier today from ABS. And we have been working some years now with US Coast Guard. We are supplying the whole fast response cutter fleet of US Coast Guard. And we have been working on transmitting data from the vessel and to their onshore database. And that happens to be inside the Homeland Security system in the US. So we have been working a lot with these kind of issues. So we are quite close to solving it for now. I guess tomorrow is a new challenge. This is the simple way of explaining how the infrastructure of the system is. And then I would like to say something about monitoring. What do we mean by monitoring? What are we monitoring? What are we discussing? And we have three types of monitoring focus. One is the stress monitoring, and this goes for ships. It goes for any kind of physical structure, because this technology can be utilized on any kind of physical structure. We have solutions for windmill parks, for composite repairs on airplanes. We have for hull stress monitoring on ship design, and structural monitoring for offshore assets. And what we're monitoring is typical stress, and that's with a focus on the overloading situation based on given limits, because all monitoring is relative. So we need the engineering companies or designers or the classification society to give limits on what we are monitoring. So we are the specialist on monitoring, not the structural part. And the second part is fatigue monitoring. And that's mostly for the post-analysis to see the consequence of the operation and what the fatigue cost of the operation is. The third thing is impacts and slamming, which is often monitored by local stress measurements or accelerometers. When we talk about stress monitoring, it's typical bending, deflection monitoring. That's what we talk about. Hogging, sagging, overloading from cargo and ballast operation, wave-induced overload, and unexpected loads from damage. You got the picture? Okay. And the second thing is fatigue monitoring. And when we talk about fatigue, there are 4 assumptions that are made about fatigue. And number 1 is that fatigue is due to cyclic loading of the material. And 2, fatigue damage depends on the stress range, as shown also in this SN. This picture is from DNVGL's calculation guideline, and it's showing 3 different standard SN curves used by DNVGL. And 3, the number of cycles to failure, also defined as fatigue life, may be characterized by SN curve. And 4th, fatigue is a reversible accumulation process, and according to Meiner-Palmgren rule, the effect of every load cycle can be accumulated to a total damage parameter. And also rain flow counting is a part of these methods we are using. And what is a fatigue rate? This is very much defined by classification societies. We are having 30 minutes intervals for finding and defining the fatigue. And when we talk about the fatigue budget, that's life cycle of the, for instance, a vessel, a boat. If you have a boat, it's going for 20 years. After 20 years, it's normally end of life. And for the monitoring part, we will say that when the vessel is brand new, or the material or structure is brand new, you start with a fatigue level 0. When you reach the fatigue level 1.0, you have reached what is defined as end of life. But end of life doesn't mean that the vessel is breaking down and collapsing and sinking. It's a defined term there too. When you have C equals 1, that's the fatigue rate. You should expect 2.5% of representative details to show fatigue cracks. It can be essential, it can be crucial, it might not be. But you will anyway have the control based on different kind of rules and definitions within the industry. Under normal conditions, fatigue rate on an asset or a vessel is much less than 0.1. We have seen a lot of voyages with almost 0.0 fatigue on a journey. But we have also seen, I've personally seen analysis showing up to factor 76, which means you are burning up 76 days of fatigue life in one day. And if you have a 10-day journey with that kind of fatigue rate, you're spending 2 years of fatigue life during 10 days. And this is happening quite often in the North Sea, where it's close where I live in Norway. And we see that very many other places also, where you have this kind of harsh weather situation and you get these high levels of fatigue. But the thing with fatigue and these high levels is only for a brief time. It's only for a short time, maybe 1 month a year, and 11 months a year maybe, or 10. It's nothing. It's quite calm. But that 1 month or those 10 days or 14 days or whatever it is, it might cost you several years of life on the structure. And that's what we can measure and say something about. So that was the definitions. Then I would like to show you, in the Middle East we haven't done any offshore structures yet. We have a lot of ship owners in the Middle East as clients, but no offshore structure, so I'm using European examples. And this is a brand new one. It's a FSO built for Statoil. It's called the Heidrun B, or B in English. It's an FSO where we have what we call a FPSO solution. And this solution is monitoring global stress, local stress, and focus on known problem areas, also based on finite element model or other experience. And on this kind of designs, we know that they have a lot of issues in the waterline, in ballast situation and loaded situation. So this is a specially designed solution for this kind of vessels. And when we talk about the light structure fiber optic technology, it can be utilized on any kind of physical structure. What we do a lot of research and develop methods for monitoring the issues on specific designs. I mentioned that previously that we have concept for offshore, onshore windmills. We also have sloshing monitoring, ice load monitoring, different kind of concepts, which I would call. But this one is built on HMON, DNV-GL rules. Maybe not so strange as Statoil is the Norwegian oil company. The next project, I assume that many more of you know about, the Goliath project, which is a Sevan design. It's a barrel design. It's quite enormous. I think the biggest ever built of this kind. On this solution, we are monitoring on 4 different levels. This design has a bilge box at the bottom for stability and buoyancy. It will create vertical forces that will create stress level in between the bilge box and the hull here. So we are monitoring that. And we are monitoring inside ballast tanks. As this is a light-based monitoring solution and is based on passive monitoring, this is submersible technology. It's got IP68 certified down to 60 meters. So we put them into ballast tanks because there's no human there. During operation at least, I hope. And then we have monitoring in the waterline of this vessel. And we have the splash zone of the vessel. And we also have this low cycle fatigue. And then I mean really low cycle. You know, ballast cargo tanks. Maybe have a cycle of 1 week, maybe have a cycle of 2 weeks. But it will create opposite pressure on the walls between the cargo hold and the ballast tanks. this one. And also, we did something for the Norwegian Navy a few years ago called MCMVs, Minesweepers, mine countermeasure vessels. And as you can see, they're quite square in the design. And it's also, as you can see here. So you cannot use a typical I-beam theory behind this. So with the help from DNVGL and other engineering companies, we were able to develop a matrix method of seeing the forces. Like this. I will not go into the formulas because I will get stuck quite fast. But this is showing a section of the hull where we do proper monitoring. Of course, how we are going to monitor this and what kind of sensors we are going to use, if we are going to monitor in 1 axis, 2 axis, or 3 axis, depend on the mission of the monitoring. And that's predefined in the engineering phase. And then we took this experience and knowledge and we brought it into this. This is ICTIS CPF. That's the world's largest semi-sub. It's now being transported to Australia, owned by INPEX, a Japanese oil company. It's going to lay offshore Australia for 40 years, never to be dry docked. So that's the life cycle of our monitoring part of the solution. The sensors, the cables have to last for at least 40 years. And the things are that we are monitoring on the pontoons and the columns. There are 4 pontoons, 4 columns, and we are monitoring 6 different global forces on each part, which means 48 different forces is being monitored on this structure. It's not only global bending, it's torsion. And as you see, some of these have 2 directions, some have 1 direction, and that is which direction we are monitoring in on these specific locations. And of course, the whole sensor arrangement is located inside the ballast tanks on this. It says 80 sensors, but actually the correct is 89 sensors. And everything about the design is based on engineering and analysis. Dr. Guma, I can happily send you the presentation afterwards, so you don't have to take a picture of all of this. If you like, no worries. Yes, absolutely. Anyone who wants to have it, please give me your business card and I'll share it with you. When we talk about, before I take the last slide, that's a project we have done together with Total for an FPSO called Egina, which is the biggest FPSO ever built. We have introduced a new kind of thinking, and that's what we call IMMS, Integrated Marine Monitoring System. And that's where we compare theoretical models with real monitoring live in real time. So you get, if you have a deviation in the system, you can backtrace it and find why you have a deviation. I will show you on the next picture here. We have a fatigue tool, a fatigue calculation tool, and then we take the theoretical design, wave and draft, RAOs, run through a fatigue tool and get a predicted damage. So it's a pure theoretical value. Then we take actual wave monitoring and draft, combine it with theoretical RAOs, run it through the fatigue tool, get calculated damage. And that's a semi-theoretical model. Then you have pure monitoring, which is based on either cold spot or hot spot damage monitoring. When you have a hot spot, you often have development of heat. And as our sensors, they can take minus 200 degrees without any issues. But when you go above 70, 75, 80 degrees, they will melt. So therefore, instead of monitoring inside the hotspot, we put the sensor at a distance from the hotspot, and with the help of stress concentration factors, we are able to establish the forces inside the hotspot. And this is all these models is being run all the time, in real time, and compared to each other. And the same second you have a deviation in any of the models, the system will tell you. And this is what we have developed on behalf of Total, the French oil company. I would also like to say something about monitoring versus modeling. Because in the 1990s, we had the feeling that theoretical models, loading computers, represented the truth. And Hull stress monitoring solution was just nice to have. And it was used in addition to theoretical models. And theoretical models was valued more than the monitoring part. But what we see today is that more and more governments, authorities, classification societies realize that loading computer or theoretical models are in some cases too simple, and they need added the detail of monitoring. And we see now about the national safety authorities within the oil and gas industry in Norway, Brazil, UK, Australia, Canada. They have, it's the last drink now. All these governments has now, and authorities has changed their attitude. And for instance, in Norway, you're not allowed to put a new offshore asset offshore Norway with a new design without having some kind of monitoring on it. And we have met also these national authorities, safety authorities, in all these other countries too, especially Brazil, UK, Australia, they say the same thing. So we are moving towards a monitoring society. We still need all the engineering companies, because we need input to our systems. And as monitoring is relative, we need limits. We need to understand the structure. What is the issues with the structure? Where do we put sensors? What are we to monitor? All these questions need to be answered by competent people like the engineers and designers. As my previous speaker, Mr. Satya, we need companies like that for input to our own systems. So to cut it short, our monitoring technology can give real-time decision support for the master and the crew. Alarms are given when you exceed stress levels. Design parameters, for instance, if they are, or classification rules. You learn about the limits and consequences for asset during various sea states. By knowing all these things, it's easy also to transfer competence to the followers. And it's easy to increase the competence for both onshore and offshore crew. And this is data-based, and you have analysis, you have reports, so you don't lose the competence, even though if you lose the crew, if you change the crew, you will still have this competence in-house. And of course, by knowing how to operate the vessel, you can do so without creating unnecessary damage. In my world, damage is fatigue. And hence, also keep your OPEX down related to structural issues. Of course, this system can never avoid an accident or incident. But you, as an owner or operator, you will have the opportunity to have status of this structure at any given time with post-analysis. Of course, you will also have this IMMS system, which I was mentioning in my last slide on this Total GINA project. It will not only give you a warning when you have a deviation, but it will also give you the root cause of the deviation from the system from a system perspective. And we are now, I would like to end with telling that we are here with the Tritech Power and Automation, which is our local representative in Middle East. And these guys are trained for service and support of all the systems we are selling and delivering. And by today, we have most of the RasGas, Qatargas fleet, United Arab Shipping Company, Adnatco, Oman Coast Guard, some of our clients in the Middle East. And hopefully, the offshore industry in the Middle East will also realize that this is, by now, the most advanced technology for quantification of uncertainties, as we can do today. Thank you very much.
Thank you. Our next presentation is going to be made by Mr. Ahmad Yusuf. Mr. Ahmad Yusuf is the founder of Aquatic Architect Design Studio and the innovative mind behind the acclimation design philosophy, which has been inspired during his earliest stages in the architecture field. He focused his research on how to revolutionize architectural designs that better adapt to weather and climate changes. Ahmad is also known for his ventures in innovative and upcoming construction technologies and 3D printing technology. By realizing the potential values of the sea, he has pinned down the water element as the guiding tool for acclimatation. Ahmad Yusuf completed his bachelor's in architectural design at the American University in Dubai, during which he founded The Hub, an architectural model making and 3D printing service company. Ahmad has been featured in prominent publications around the UAE for his entrepreneurial accomplishments and for his prestigious Architectural Design Award. Please welcome Mr. Ahmad Yusuf.
That's fine.
Hi everyone, I'd like to thank you for inviting me in here today. As you can see, we're an architecture firm, recently established here in Dubai. And we are the first architecture design office solely focused on aquatic developments emerging from the UAE, not from abroad. We have our partners in the Netherlands, Water Studio, architect Koen Altes, who've been working together for a number of years into developing this concept. I'll show you now a different perspective of how we look at the offshore market and what we can do further with the sea than petroleum and then dredging and all that. So what we're proposing, or what I'll be talking about, is adaptive floating cities, which is something that we consider a need for the country here in the UAE due to the upcoming slides that I'll be showing you. It is crucial to understand the value, benefit, and purpose behind floating architecture and make use of its maximum potential. We have seen lately a few projects coming in, floating projects coming in, but then again, each city develops or adapts in a certain way according to their own requirements and needs. One of these requirements or reasons for why we build on water in the first place is excessive dense urban structure, struggle with the sea level, such as the Netherlands, for example, where they're below the sea level, or to combat sea level rise that is anticipated in the near future. flooding is also one of the reasons why other cities float, so that they can adapt to the flood. Instead of having a static structure or static housing, the house would have a floating base that enables it to float up when the flood takes place. So why should the UAE adopt floating developments, and why should it be any different? Our reasoning for why we should float is completely different from the slides I've shown earlier. Okay, so basically to acclimate, we go back to how organisms adapt, or how we as humans adapt, even our designs as architects and builders and whatnot, and how we think how we should evolve. We ask ourselves the very most important question is, what are we adapting to? What are the catalysts, the forces that are pushing us towards that adaptation? Once we realize that, we start realizing what's the best habitat to apply such adaptation, and what are the tools that we can use in order to achieve such adaptation, in order to reach the outcome that we're looking for. So in the UAE, we have a unique weather condition where we have 7 to 8 months of hot or humid weather condition. And that is about 65% of our entire year. If you think about it, if you have an outdoor space, any given project, you would have 60% built area, and then you would have a certain percentage on the outdoor area. Throughout 7 to 8 months of the year, that area is unfunctional, it's not used by the end users, and therefore that's limiting the designers and builders to expand more on outdoor structures and outdoor environments. The second catalyst is the water consumption and the increasing demand on water consumption. We know that 90% or almost 90% of our consumed water in the UAE comes from desalinated seawater. So maybe being closer or having a more direct access to seawater is something that can save cost and less activities on logistics and transportation and whatnot. The third catalyst is the energy again, the demand for more energy. And finally, the rise in sea level, which is, I mean, we're looking at 2100. If I know we're thinking about the dams now and whatnot, so that can give us a bit more time. But eventually, we need to have a certain strategy that we can also implement alongside other solutions. So realizing all these factors, we realize that we need to have these traits in order to achieve our goals and to adapting to the catalysts I've just explained. We need to enable our designs to be more efficient and adaptable in terms of designing outdoor environments where they can adapt to the weather condition, bringing outdoor spaces indoors and indoor spaces outdoors. Direct access to seawater for easier access for desalination and water purification systems. We need a natural source for energy, again, where the new direction and should have been long ago, the direction for new energy in the UAE is to harvest energy from natural resources. So we need maximum exposure to UV rays, since solar is the most prominent or the most dominating sustainable source for energy. But then also the sea is one of those sources. And flexibility to adapt to the natural anticipated occurrence of the sea. So we need to be flexible in that form. So to adapt is to become flexible. That's what we pinned down. And to be flexible as a static form, you need to achieve or find the perfect habitat to enable that. And that is, in our perspective, the sea, where it enables static forms to move around freely without the struggle of being that it would have being on land. This is the concept that we have developed. I mean, there's always the floating chamber or the floating element of any floating structure, such as ships, boats, and other on-water developments. But we have integrated an addition to that, which is an adaptive platform, which is what enables spaces to move back and forth, as we'll be seeing later on, and eventually the end user space. So as a regulation or as a requirement, the government had pushed and had opened doors for more sustainable solutions and have always asked for, more specifically when it comes to the sea, the islands, they have specified that there should be more than 60% of self-sufficiency for such projects. And such, in the UAE, it shouldn't be an option, or it shouldn't be an option. It shouldn't be an option that you would implement such technologies. It should be a must that if you're going to build on water, most ships are by nature or by profession is to some extent self-sufficient. And that should be the case also with developing residential or commercial projects on the water. This is the adaptive platform that we have developed or integrated into our designs. As you can see, I don't know if the image is clear for you or the drawings are clear for you. It's a simple system where you have a false slab integrating a railway or a passage for a railway that enables a certain platform to move in one direction, in a restricted direction, in order to achieve what we will be looking at next. Again, this is just how it's stacked up, the floating chamber with all the sustainable elements that can be used, the adaptive platform, and then eventually the end user space. So what does that give us? This is an example, a conceptual example, again, of how a floating city could be. And this is a scenario that we can see in a hot weather condition or a less favored weather condition to be on the outdoors. And then it evolves in that way, bringing more outdoor spaces to the environment so people can enjoy walkways and the natural weather and whatnot. And finally, this is the final adaptation of it. So you have an entire adaptive city that can allow for, we're not talking about opening facades or windows, we're talking about an actual outdoor environment, which is something that we enjoy most abroad. So we'd be transferring such interior space from that to that. Utilizing the same space area, you're not wasting the built area whatsoever, and you're adding more, or you're upgrading basically the experience that the end users have. Another variation to it is this conceptual design as well, which is a recreational project that adapts in such way. So you can see how the indoor places, which are enclosed at the moment, are all outdoors, or it creates an outdoor environment. So where can these projects take place? The coastlines, islands, or protected waters. We're not talking about open sea or anything of that sort where these projects would never be stable enough. It would also be difficult to moor down. But then how we see the coastline, islands, and protected waters in the UAE are of the same value as petroleum, let's say, because they have great benefits such as the previous slides have shown, where we can produce our own water. It can reduce the impact on the salination plants. It can produce clean energy, whether from solar due to the exposure that we have in the sea, or from the motion of the sea itself. These are just some concepts that we've worked on, but they have never taken off due to costs and whatnot. And also the regulations by Tasnif had recently been, let's say, more accepting to such projects, and we are actually working with them on one of our first projects that will be launched soon. Again, local housing or residential, floating residentials, interior perspectives of such designs. Water sports club, we can have related water or certain projects that are related on water that can be actually on water to cater best for the users. And finally, agriculture. I mean, direct access to the sea, clean energy. It can sustain farming in the UAE in large scales. Also, the ease of expanding these farms without having to extend logistics, extending infrastructure, extending all that to sustain these farms. Eventually, building on the coastline, floating developments can help mainland gain excess or extra water supply, also energy supply, depending again on the regulations and what are the requirements of the produced water supply and energy from these floating developments. Again, the same concept with the islands, where we can have green islands instead of sand islands due to the projects built surrounding these islands and then feeding it later on. Again, in the sea, utility hubs, we can have pods to transfer stored energy produced from certain projects into that hub that can assist other projects, that can assist for emergency, or even transport it to mainland. And the same works with water. Floating developments are beyond architecture and planning. It demands more than aesthetics. It demands a lifestyle. It's a creation of a collective series of a different environmental and economical fabric. The way I see it is that developing or designing on water requires a much broader mindset, more hands to be joined together from all different departments: agriculture, petroleum, development, authorities. All these parts need to come together in order to regulate it in such way that can help open a completely new market here in the UAE post, petrol and whatnot. Thank you so much for your time. I hope I made it pleasant for you. In Netherlands, we use concrete for most of the projects that we work with. In Dubai, at the moment, we're working on a project where we're using a steel foundation. Again, that's due to discussions with Tasnif. So the first prototype will be made out of steel. Yet, concrete base has less corrosive elements than steel in the sea, and that's why we use it more in the Netherlands. Yes, 100%. 100% floating.
Interesting.
Any questions? Thank you.
I'm sure there'll be a lot of questions. Thank you very much. That's a pretty interesting topic. And our last presenter is from Marina ILIC, Senior Market Analyst, Marina Illick. She's the Senior Market Analyst from DMS Global. Marina is a Senior Market Analyst at DMS Global and the head of the UAE Project Research at DMS Projects, a division of DMS Global. Marina has graduated with a master's degree in marketing from Queen Mary University in London, in the UK, and has since demonstrated her expertise with a history of working in marketing and business strategy, corporate events, communication, market research and analysis. Originally established in 2000, this project tracking system tracks projects throughout the Middle East, but has since then grown to undertake a global coverage of 14,000 projects in over 50 countries across 14 major sectors with 9 offices around the globe. Using DMS Projects expertise, DMS Global has gained the ability to use this knowledge to expand to other business activities. Please welcome Marina for her presentation. Thank you, Marina.
Hello, good afternoon. So this is the last presentation, so I'm gonna make it quick so that all of you can go home and, carry on with your lives. Okay, so I'm here today to discuss current ongoing projects in the GCC offshore sector. So I'm going to start off with a bit of an introduction. So the GCC has always been an energy-focused region, which in the recent years started paying more attention on the offshore potential to meet the growing energy demand and gain a competitive edge. So the GCC countries have increased focus and efforts towards exploring their offshore fields to increase production capacity of oil and gas and diversify the energy sources. Now, in terms of the countries, Qatar is the largest investor with 17.8 billion and 7 ongoing projects, amounting, like I said, 17.8 billion US dollars, followed by UAE at 10.4 billion, and then Saudi at 8.6 billion. So I'm going to go through each country and just to discuss what their current project situation is. So Kuwait shares a long border of 250 kilometers with Saudi Arabia, and in 1969 the Neutral Zone Agreement was signed, marking each country responsible for its portion. The resources in the area are not affected by this agreement, and oil continues to be shared equally. Most of Kuwait's oil feedstock comes from onshore fields. However, some reserves situate in the neutral zone. These are Khafji, Hut, Lulu, and Dora oil fields. The exploration of the neutral zone and Kuwait Bay started in 2015 with large transition zone survey to determine further development opportunities. KOC was expecting to continue the exploration activities in 2016, but the drop in oil prices caused continuing delays. The exploration of the neutral zone and Kuwait Bay shows that the country is ready to shift to non-traditional sources to satisfy the rising demand in both international and domestic supplies. Now, Bahrain is keen to increase its oil and gas production in order to reduce dependence on supplies again from other countries. And BAPCO is currently undertaking feasibility studies to explore the offshore territory. In 2008, Bahrain's National Oil and Gas Authority signed exploration and production sharing agreement for Bahrain's offshore blocks 2 with Thailand-based PTTE. And in late 2007, the two shared agreement for blocks 1, 3, and 4 with Occidental Petroleum. So exploration activities in all 4 blocks started in 2008, but were abandoned in 2013. Hydrocarbons discovered in all the blocks, they were discovered, but the quantities were not above the commercial scale. But with more advanced technologies and solutions, Bahrain hopes to find new discoveries of commercial quantities. In terms of Oman, Oman is the largest non-OPEC producer of oil and natural gas in the Middle East, and its hydrocarbon sector accounts for almost 84% of the revenues. PDO is responsible for more than 70% of crude oil production, and Block 8 is Oman's only offshore producing block with average of 9,000 barrels. The main production fields here are Bakka gas, condensate, and West Bakka oil and gas field. Another major offshore player is Masira Oil Limited, which is 85% owned by Rex Oman. It made the first offshore oil discovery in early 2014, and few more wells have been drilled ever since. And in early 2017, Masira Oil Limited received capital injection, allowing drilling activities, but again, the downturn in the oil price, extended well testing, and early production plans have been put on hold for re-evaluation and for more cost-effective methods. Furthermore, Oman's proximity to Iran grants its opportunity to export Irani gas at 400-kilometer Iran-Oman subsea pipeline, which will stretch from Mubarak Mountain in Iran to Sohar port in Oman, and transfer natural gas from Hormozgan province to Sohar industrial port complex, and then to the rest of the world through vessels departing from an LNG terminal at Sur in Oman. The pipeline will have the capacity to carry 1 billion cubic feet a day. And just to quickly mention, Qatar Petroleum expects liquefied natural gas output to rise to 30% in the next 5 to 7 years. More than a third of the world's liquefied natural gas trade comes from this country, making it one of the largest producer and exporter of LNG. A few of their projects include Oxy expansion Eid El Shagnot Dome, where Oxy plans phase 5 expansion, QP Bulhanin redevelopment, Ras Gas, Qatar Barzan gas field development 2 and 3, and Shell's continued involvement with the Pearl GTL scheme. Now, Saudi Arabia, in terms of offshore hydrocarbon program, is a crucial component to meet greater production targets. Saudi Aramco is shifting resources to support its current offshore activities, drill new wells, and adopt advanced technologies to optimize output. Saudi Aramco has extensive offshore operations, which include Safaniya, the world's largest offshore oil field, and several large non-associated gas fields. Many are mature and require extensive rehabilitation over the next decade, and every year hundreds of new wells are drilled to maintain operations in shallow water fields. Saudi Aramco is also carrying out seismic surveys on the Red Sea coast. However, any potential production is still expected to be several years away. Marjan oil field increment is expanding, as Aramco needs the gas for its own petrochemical expansions and plans to set the gas and condensate to Tanajib gas plant. Zuluf oil field is considered for expansion to boost production of Arabian heavy crude through new central processing plant with 2 units of 600,000 barrels per day capacity. Habshan offshore field has a new scheme to increase production by 2 billion cubic feet a day, which will be piped onto the Fatil gas plant. And the new Arabia pipeline project will rehabilitate the existing A to B pipeline between Saudi and Bahrain, and will replace the pipeline between Dhahran and Sitra refinery plant to support Bapco's expansion plans. Now, the UAE is considered one of the leading GCC countries in the offshore drilling activities. ADNOC has been focusing on combining its 2 largest offshore assets in hope to streamline operations and overcome the downturned oil environment. Zatco and ADMA are the country's 2 offshore oil production leaders, and together expect to reach 1.7 million barrels per day this year. And as holders of Upper Zakum 750, Al Dalq, and Nasra field developments, together they aim to improve offshore efficiency and productivity. The UAE is also paying attention to the offshore gas projects to meet rapidly growing gas demand, despite the challenges of sour gas fields positioned at shallow water. The UAE is also it has several projects that I would just like to quickly mention. So Abu Dhabi Oil Company Limited, ADOC, is developing Hale offshore oil field and is expanding facilities at Mubarak field. And Zatco is expecting Al Dalq ESP installation phase 2 development completion this year in December, and Upper Zakum 750 the part which is carried out by MPCC may have some leftover works for the beginning of next year, but the majority of the works on this phase of the project will be completed at the end of the year. And there's another phase then that's carried out by Petrofac. This will be carried on until the end of next year. Also continuing with UAE, ADMA has been quite active with an aim to increase Nasser Field's oil production capacity to 65,000 barrels per day from the existing capacity of 22,000 barrels per day. Nasser Full Field development forms part of ADMA OPCO's overall plan to fast-track the development of new fields, including Satah al-Razbout, Umm-al-Lulu, and Umm-al-Lulu, to increase the company's production capacity by an additional 270,000 barrels per day. ADMA's lower Zakum oil field lines replacement is now experiencing an extension to its scope with an additional pipeline and another eight wellhead modifications, while Bu Hasir project expected completion has been pushed back to mid-2018. And now to conclude, so as mentioned, I'm just going to quickly go through each country. Kuwait's major offshore development project is the exploration of the neutral zone. KOC was expecting to continue exploration activities in 2016, but the oil drop caused delays, shifting plans to 2017, but then significant investment required for the development of the offshore area still pushes plans back. Bahrain's main offshore projects have two goals: to assess the domestic supply of oil and gas available to the country so that the resources can be fully utilized, and to augment the Bahrain supply of natural gas. As far as Oman is concerned, through the international partnerships, Oman is slowly increasing offshore exploration activities. Oman's Ministry of Oil and Gas is licensing its various offshore fields for exploration and production on a production sharing basis. Qatar is the largest investment in the offshore sector. They're also planning to restart the development of the North Field. Saudi Arabia is committed to develop mega offshore projects across the kingdom, including development and expansion of Safaniya, Marjan, and Zuluf, which are amongst country's largest offshore oil fields. And ADNOC in the UAE is planning to increase its investment towards the development of offshore fields such as Nasser and Hale to meet about 20% of the UAE's gas demand by the end of the decade. And that concludes everything. So, thank you for your time. Sorry?
How do you see the market to go in the next 1 or 2 years?
Well, I mean, everybody has this question. At the moment, from what I can see, from projects, I follow UAE. We have a team that follows, the region. But here, at the moment, the focus is on the current projects and completing them. In terms of new things, I think end of 2018. After 2018, I have been, from all the discussions that I have with relevant people in the industry, it looks like there will be more investment towards the end of next year. So that provides some optimism, definitely, because this seems to be next year, still to finish the current projects, and then at the end of 2018, there are talks about further investments into new areas. So let's hope. It does, yes, but things seem optimistic now. I think the hardest part has gone. Just 2018 to finish, and then hopefully more new things will be developed, more new jobs and new fields.
So as per the market research, the worst is over?
I think so, yes. Yes. Yeah. Good. Okay. Okay, thank you.
With this, we have come to an end of our today's conference, and before concluding,